Good morning, students. So continuing with the second unit of the ninth class. The heading is matter around us pure? Let us do first question of this lecture. This is our lecture number 2. Question 1 is differentiate between physical and chemical change. So physical change is that change in which no new substance is produced. It is only change of physical state. No new substance is produced. But in chemical change, whenever this change takes place, new substance is produced. Then physical change, it is reversible in nature. It cannot be reverted. It is temporary change. This is a permanent change. Examples in this case: solid ice changes into H2O liquid by taking heat, and liquid changes into H2O gas, steam. It is again by heating, and this change we are bringing. This is physical change. And here example we have rusting of iron. Where Fe changes into Fe2O3. So this is the chemical change. It takes place in the presence of OH ions. So this is a complicated reaction. Rusting of iron, it is a chemical change. Similarly, the combustion of carbon, it is a chemical change. So these are the chemical change where the physical state that changes and the nature of the compound is also changed and new compound is formed in this case. Now we are doing the textbook questions for 9th class. The first question is to make, we have done few questions in our earlier lecture. For example, what are pure substances? Give the difference between homogeneous and heterogeneous mixture. Then classify the substance on the basis of their particle behavior in the solution. Then we are doing next question. To make a saturated solution, 36 gram of NaCl, they are dissolved in 100 gram of water. What would be the concentration of this solution? So when 36 gram of your sodium chloride is dissolved in 100 gram of water to get a saturated solution, it means it is the maximum solute which could be dissolved in the solvent that has been dissolved. We have to calculate the concentration of the solution. This is our question number 5. Calculate the concentration of solution having 36 gram of NaCl in 100 gram of water. So it can be expressed by two ways. Number one, concentration we know, it is equal to number of mole divided by volume of the solution. So number of moles of the NaCl, they are to be calculated. 36 divided by molecular mass of NaCl, it is 23 plus 35.5, it will be 58.5. This is the number of moles. Now this is present in 100 ml of the solution. So 100 ml of the solution contains this much mole, 1000 ml will contain how much? So it will be calculated like this. You will be having 360 upon 58.5. So this will be the concentration approximately, it is equal to 6. So this is the concentration of the solution. So now if we want to express mass percentage of this solution, that can be expressed by 36 plus 100. Total mass of the solution is taken below. That will be 36 plus 100, it is 136. So 136 multiplied by 100, you will get the mass percentage of this solution. It comes out to be 26.4. This is the concentration. It has no unit, number of mole per unit volume of the solution. Then we have 6th question. How will you separate the mixture of kerosene oil and petrol? They can be separated by fractional distillation. Where to separate different petroleum product, we use fractional distillation, which is carried out in a huge steel column. The different fractions of petroleum, they are obtained at different levels of the fractionating column. Then name the technique which is used to separate butter from curd. It can be separated by centrifugation. Centrifugation, in which the heavier particles, they will come nearer to the center, and lighter particles like milk and water, they will move away from the center. Then we have salt from seawater. It can be separated simply by evaporation. Then camphor from the salt. Camphor can be separated. Camphor is a sublimizable compound. On heating, it gets vaporized. These vapors are collected separately and are cooled down to get the pure camphor. Salt will be left behind in the pan in which we are evaporating this. We are heating this. What type of mixtures are separated from the technique of crystallization? Crystallization involves the separation of the water soluble compounds from impurities which are insoluble in the water. So impure samples, they are dissolved in water and then they are filtered to remove the insoluble impurities. The filtrate is concentrated by heating it in a china dish, and when water evaporates, leaving behind the solid. Then classify the following changes into physical or chemical. First is cutting of the trees. Whether it is a physical or chemical change, it is a physical change. Then we have melting of butter in a pan, physical change. Rusting of alumina or rusting of iron article, it is a chemical change we have just discussed. Then we have boiling of water from steam to form steam, it is a physical change. Passing of electric current through water and to decompose water, it is a chemical change. Then dissolving common salt in water, it is a physical change. Making fruit salad with raw fruits, physical change. Then we have the burning of paper and wood, it involves chemical change. Cutting of the trees, it involves physical change. So these are the different classes of the changes. Dissolving common salt in water, it is a physical change. Making fruit salad with raw fruits, it is again a physical change. Burning of paper and wood, that involves chemical change. Then we have suggesting the things around you, whether they are pure substances or they are the mixtures. Water, we know it is a pure substance if it is not contaminated with impurities. Milk, it is a mixture. LPG gas, it is a mixture of 2 or 3 gases. Then bread, it is a mixture. Gold, it is a pure substance. Gold symbol is Au, it is a pure element. Kerosene oil, it is a mixture. Air is a mixture. Paper is a mixture of number of complicated polycyclic polyaromatic hydrocarbons. Then paper, common salt, it is a pure substance. Ink, it is a mixture. Curd, it is a mixture. Wood, it is a mixture of many substances, polysaccharides. Then we have wood mixture. Ice, it is a pure substance. Sugar, it is a pure substance. Soda water, it is a mixture. Then we have ice cream, it is a mixture of number of substances. It may contain gelatin, water, salt, sugar. Butter, it is a mixture. Vanaspati ghee, mixture. Lemon juice, it is a mixture. Brass, it is a mixture of zinc and copper, we know. Now, which separation technique will you apply for the separation of sodium chloride from a solution in water? It will be evaporation technique. We will be evaporating water, leaving behind the concentrated solution, which on cooling will give the crystals of NaCl. Then small pieces of metal in the engine oil of a car, how they can be separated? They can be separated by filtration. So filters are generally applied in the vehicles. Then different pigments from the plant flower parts, they can be separated by chromatography. Chromatography, it is a technique which is based upon the phenomenon of adsorption. A suitable adsorbent it introduced in the suitable column where mixture is then flown. The mixture, the different components of the mixture, they are absorbed by the adsorbent at different levels. Later on they are separated from that adsorbent by using a suitable solvent. Then iron pipe from sand, how we can separate iron pin from sand? It can be done by the magnetic separation. A magnet is brought in the mixture, it will separate out the iron pins from the sand. Wheat grains from the husk, they can be separated by gravity separation. By blowing that wheat containing husk in the air, the husk will move away from the wheat particle, they will fall apart, they will make a separate heap as compared to wheat. And then we have fine mud particles suspended in water, they can be separated by filtration as well as by centrifugation. Now write the steps used in making tea. So steps used in making tea, we can describe it chemically. First of all, take solvent water, put it in the pan used to make tea, and boil water, add to it leaves and other things what you want to add to your tea, and again boil it, then add sugar, followed by the addition of a mixture, that is milk, and then boil it and filter it. Tea leaves will remain in the filtration pot while your tea will come out in a cup. So it is used for the sipping. Then we have the different. The table is given. Potassium nitrate is 21 gram at 21 gram dissolved at 283 Kelvin. At 293 Kelvin it is 32 gram. 313 it is 62 gram. At 333 Kelvin it is 106 gram. At 353 Kelvin it is 167 gram. It means when we are increasing the temperature, the solubility of the potassium nitrate or solute, it increases. It means this solute requires heat for its dissolution, and that is being supplied by raising the temperature. Therefore its solubility will definitely increase in the solution. Now we are having a question. Now let us first make a table of this. So this is first solute KNO3. It is dissolved at different temperature 283 Kelvin. First of all, we have the different temperature 293, 313, 333, and we have the temperature 353. So these are the temperatures. Then we see the solubility. Solubility is 21, 32, 62. Then we have 101 at 333 Kelvin, 106, 167. So when temperature is increasing, the solubility is increasing. It means KNO3 dissolves endothermically, it requires it for its dissolution. Then he says what mass of potassium nitrate would be needed to produce a saturated solution in 50 gram of water. Saturated solution of KNO3 that is formed at 313 Kelvin. This will give the saturated state. So 62 gram is dissolved in 100 gram of water. This is saturation. Then he says how much KNO3 is required to prepare saturated solution in 50 gram of water. So water volume of the solvent it is made half, therefore solute will also be half. So 31 gram of KNO3 that will be dissolved in 50 gram of solvent to give you saturated solution at 313. So this is the way how to solve the problem. Then he says that find the solubility of KNO3 at 293 Kelvin. What is the solubility of KNO3 at 293 Kelvin? At 293 Kelvin, it is dissolving 32 gram in 100 gram of solvent. Then what would be the solubility at 50? What will be the solubility in at 293 Kelvin? So solubility of potassium nitrate at 293 Kelvin it is 32 gram per liter, and at 283 Kelvin it is 21 gram per 100 gram of water. At 333 Kelvin it is 106 gram per 100 gram of water. So solubility of potassium nitrate that increases with the increase in temperature in this case. Then we have question, explain the following. This will be our question number 4. Explain following. Number 1 is saturated solution, supersaturated solution, saturated solution is that solution which contains the maximum amount of dissolved solute. Beyond this point, no more solute can be dissolved. And supersaturated solution, it contains more solute than which can be dissolved at saturation state. For example, the solubility of this sample KNO3 at 313 Kelvin is 62 gram per 100 gram at this temperature. If this sample is allowed to cool, then definitely some of the salt that will come out of this solution and will settle at the bottom. Therefore, more salt can be dissolved in this solution by heating this solution again. That will be giving us the supersaturated solution. Then we have the pure substance. As we have already defined pure substances are those substances which have the particles or of only one kind. They are called as pure substances. Then we have colloids. So colloids are those substances whose particle size in the solution state is in between 1 nanometer to 100 nanometer, and the particles they are a bit larger than the sizes of the true solutions, and these particles they can be even seen with the naked eyes also.